to start working on Delta PLC, we need to download few of the softwares. There are two software which we need to install. One is COMMGR, that is the communication protocol developing software, and the other one is WPL software, and links are provided from where you can download these two softwares. After downloading, we have to first of all start working with this communication manager. We'll click on this. After clicking, it will not, there will be no window that will be appearing on the screen, so you have to go down, and here from here we can open this, right? And now we have to click on add, and after adding, if you have connected the PLC, then it will show the COM port. Since we have not connected, that's why this is not showing the COM port. But anyway, we need to select this RS232 option, fine. And after that you can click OK. Since COM port is not there, there is no hardware connected, that's why it's showing OK. So you can make cancel and close it, fine. So it will not make any effect, our simulation will work out. Now we'll open the another software, WPLSoft, which you can open, which you can download from this Delta website. I have given the links, so you can download. And now after that, what we will do, we will open this software, and let us see how to simulate any kind of logic which we develop. So let it open. So here is the software. Now I will begin with a new file. So I close the earlier files from here, and you can now go to the new, okay, and you give any program, let us say mechatronics lab. Now model, we have to select PLC. We are not working on VFD or any other device, so we have to select PLC, and we are going to work on SS2 device. So we will select SS2 here, so that in hardware we will not face any problem. And already RS232 is selected here, there is no COM port here, fine. And file name also you can select here, okay. So I'm just leaving it as it is, and now you can click OK. Now a new file is going to open, and you have to maximize this ladder diagram program mode. So this I have maximized. Let us say that I have to switch on an output using an input. So here you can see the last row here of menu. So here you can see F1 normally open contact, F2 normally close contact. So we have to use normally open contact, and we have to use an output coil, fine. So using one input I have to actuate an output. So I'll click on over this. It will ask what is the number. So X is the name of input, and device number X0, let us say. You can give a particular number here which will be connected to the real-time PLC. So I take X0, and after that I have to connect the output. So I'll click here, output coil, and it is, let us say, Y0. Automatically it is giving Y0, okay. So now this small code is ready. We will first of all compile that. For that we'll go to the compiler and click over here. Compilation is complete, there is no error here. Now we'll save it, fine. So dvp9 was the file name, so it is saved, and you can see that after compilation this last row is, or rung is, also added. Now we have to simulate. We don't have the hardware, and we want to simulate this one. So for that, what we have to do, here you can see a small gear is made, and when you bring your mouse here, it is showing simulator. So we have to click this simulator, and after that we have to go to online, this symbol which you see here, online mode. So we will go to the online mode, click yes, and after that you have to go to run mode, fine. So these three options you have to do: simulate, online, and run. And after that, now you can check it. How will you check it? Click here, right click, and set on. So the moment you make it on, obviously you should get an output which is shown here, fine. So this is how a simple simulation can be done. Now in the next step we will see how to add some other counters and timers. So now here what we will do, I have to come out from the simulation mode and make some other program. So I'll click here, on the simulator switch again, and it will come out from this one. Fine. Let us say I have to make a latching here. So latching means I have to parallelly connect the Y0 here. So for parallel connection, I have to bring down a line and make another switch here. So for bringing down the line, I have this FS vertical line here. So I have to make a vertical line here, and then this I think I have to delete end. Okay, this I have deleted, backspace, and I'll bring the cursor here and bring the another switch, which is basically Y0. Fine. Now here I have to set normally close switch for stopping. So F2 is normally close switch, and let me take it as Y1. So now X1, X0 is going to be switching on the Y0, and Y0 is X1 is switching off. Fine. So that is how we can create it. Let us simulate. Before that, we have to save it and then compile. It will add end row, and then go to simulate online and run mode. Fine. You can see a light blinking here which says that it is in simulator and in run mode. So set on, and you can see that it is on. This fellow is for switch off. We'll set it on and it will go off. Fine. So that is how we can simulate a simple switch and output. Now let us see how the timers and counters are working. So for that, what we will do here, you can see here there is a big menu shown here in which you can go to basic instructions. Fine. Open this, and you can see TMR for timer and CNT for counter. Let us quickly see how to add timer and counter. Let us think about a logic in which we would like to switch on output O1. I'm pressing back space to delete this. Fine. It's very simple and easy. So using Y0, I will energize a timer, and timer will have some delay, and using that delay I will energize a output Y1. So first Y0 will switch on, and after some time Y1 will switch on. So first of all, using Y0 I need to switch on a timer. So I could have, I can add the timer directly here, but let me make another row. So this is Y0, and from this I have to select the timer. So how to work out that with timer? So you just double click here, and you'll be able to see the help here. So we have to write TMR. Okay, TMR is the code for timer. Fine. So I understood that. Now what we will do, we'll go to here, and we'll make a double click here. Just try to understand. I would like to make timer here, so I try to understand what is the short name. So it is TMR written over here also, and it's shown here also. Now double click I'll do here, and this instruction will open. So I will write TMR here, and then I'll go here for help, click this fellow, and a window is going to appear here. So in this window, it says that how to add a timer. So there are two parameters for timer, S1 and S2. S1 asks what is the name of this timer. So the name of this timer is T1, let us say, or T3, T4, whatever is there. So let me take T0 by default, or T1 let us take. And then it is the counting. So counting is D or K, decimal or float we can define. So let us take it in integer values K, and let us take the value here 20. Okay, fine, and then click OK. That's all. So it will add a timer. Name of timer is T1, and K20 is the counting value. Now this timer will act as an input here. So I will double click here and write TMR, or not this one, and select this switch and show that it was timer and T1 timer. Okay, so it is now here. I have to add an output. So output Y1. Okay, so now in this, let us save it and compile. Fine, and then go to simulate online and run. 3 process. Fine. Now click here, switch it on. You can see this number microseconds. Fine. Quickly it has come to y1. Now when you switch it off, switch it on, timer is off. Make it off and then set it on. You can see, you can focus here, K0 value is quickly changing and going up to K10, K20. Switch on and so we have to, I think we have to again go to on mode, run mode. It was basically on, that is why it was not happening. So for off, it has to be there in this particular state. Set off. Now this has to be off. Fine. And this has to be off. This has to be on. Now again it has to be set off. Now you can again switch on, set on. You can see it is going up to here. Now let us say that we have to add a counter here. Fine. Come out from this logic and I'll create another logic in which x1 will count that how many times we have stopped the output, and if it goes beyond 3, another output y2 will switch on. So what I will do, I will add another row here. Fine. So I'll delete this, not required, and add another rung here basically, which will take the input from x1 and will be counter C and T. So what I will do, double click, I'll write C and T. This is the requirement in Delta PLC. We need to know the shortcuts, and then you give the input from C and T. This is counter number 1. Value is K, which is 3, integer value, which is 3. Okay, so you can see here the values shown here, C0 to C119, and set value K0 to K32, and so on. D has got larger values, okay, double, and this is K. Fine, so let us take it as 3 and press OK. And if you want to know something more about that, you can click over this and then you can see what are the different two values. Okay, so we are not going to this one, so press OK and you can see C1 and K3. Here we can make some change. Let us say 20 was, if it is very high, you can make it here, let us take 100.